Future Hacker Life Path Future.
Hello everybody and welcome to Future Hacker. I'm your host, Maria Taiji, and today we're talking to Dr. Rebecca Ressman. Rebecca is a senior project engineer and policy analyst at the Aerospace Corporation. She provides technical support to the headquarters of the United States Space Force. She's also a policy analyst at Aerospace Center for Space Policy and Strategy. Before joining Aerospace, Reesman was an American Institute of Physics Congressional Fellow, working space, cybersecurity, and other technical issues for a member of Congress. Prior to the fellowship, she was a research scientist at the Center for Naval Analysis, designing, executing, and analyzing wargames. Hi, Rebecca. It's so great to have you with us today. How are you doing?
Hi, Maria. Thanks for having me. I'm doing well.
So, Rebecca, I'm curious, what happened in your life journey to draw you to space and science? Your background sounds really cool. Is it something back from your childhood or the path it just happened in your life?
Yeah, I guess I've always been drawn to space, and I think that's something maybe a lot of people when they're younger at least can relate to. And I guess, maybe I never grew out of that. I think space is very sort of mysterious and interesting with a lot of unknown. Most of the universe is not on Earth. Most of the universe is the vastness of space. And I, always like understanding things and learning stuff. And so, space is sort of a natural thing of interest. I've also, always been really good at math, and in college studied physics with a focus on astrophysics because space. And really, I kind of somewhat stumbled into the national security side of space, but I think it's actually a, particularly interesting and challenging field. I liken it to the sort of optimal intersection of three things, which is science and technology, policy and strategy, and international relations. And I mean, lots of fields, sort of live at that overlap. But again, I feel like national security space is sort of the optimally interesting intersection of those things. So I find it to be a really exciting field to work in. That said, my dream job is still to be an astronaut. I have applied twice and NASA has rejected me twice, but perhaps third time is the charm.
Don't give up. Don't give up. We're all cheering for you, Rebecca. So I want to go straight to it. And, the reason that we wanted you on the show, you wrote this paper about how to think about space war, right? And how our imagination is wrong when using movies as a reference, which is something that we naturally do growing up with all those references. Could we cover the main points so our listeners get a better picture?
Yeah. So like you said, sci-fi depictions, while really fun to watch on the big screen, are not representative of what is possible in Earth's orbit. I should also preface that I love sci-fi movies, TV shows, books, and all of that, but unfortunately they often, not always, but often depict things that are not possible. So for example, the sort of star cruiser concept is an extension of what combat can look like in the air domain, but it is not possible around Earth. Instead, all spacecraft or satellites are constantly moving, orbiting Earth in an elliptical shape. They can't move in like straight lines, for example, as shown in movies. And so, the concept of a spacecraft chasing another one would be more like sort of a slow dance in space, which is much less exciting to see on the big screen. And, it's probably why they don't do it. But as you said, so I sort of wrote a paper on the physics of conflict in space, and ultimately I explain orbital dynamics and how it dictates how things move. But I also sort of do it in the context of conflict and sort of what it means with that context. And so the paper sort of framed around 5 key points, and I'll sort of quickly hit on those 5 points. So the first one is that satellites move quickly. So depending on what orbit they're in, sort of commonly used Earth orbit, their speed is anywhere between about 7,000 up to 18,000 miles per hour. And so that is, way faster than anything we sort of deal with on a regular basis down here on Earth. So it's sort of just hard to fathom things moving at that kind of speed. The second key point is that satellites move in predictable paths. And so there's a strict relationship between the speed and the altitude at which an object in space moves. Any object at a lower altitude is moving more quickly than objects at higher altitudes. And so if you want to, say, change your speed to maybe speed up and try to chase somebody, you will also be changing your altitude. And so you kind of can't defy that relationship. The third thing is that space is big. And while that sounds very obvious, it's still really hard for people to sort of comprehend just how big it is. So thinking about just the space or the volume around Earth's orbit, where satellites mostly live, is 50 trillion cubic miles, or about 190 volumes of the Earth. So that's just a very big domain through which to think about any kind of strategy or operational execution or what have you in the context of conflict or otherwise. The fourth point is that timing is everything. And so since the nature of conflict often requires two systems, maybe two weapon systems, to get close to each other, the constant elliptical movement of satellites paired with how big space is makes timing a very important consideration when doing any kind of planning. The fifth point is that satellites maneuver slowly. So I said they move quickly, but because space is so big, any kind of purposeful maneuvering seems relatively slow. Again, really important from a sort of planning and strategy perspective. So those are the 5 sort of overarching key points that we frame a lot of the paper around. There is one other sort of important variable to highlight, though, which is it's called delta V in engineering terms, but it's basically the available energy that a satellite has, and that is a limiting factor in any domain. But currently, satellites are a little weird because they are launched with all the fuel that they will ever have. So, that's like never being able to refuel your car or your airplane or your ship, which obviously therefore limits the number of maneuvers you can do. And, it sounds crazy to think that you would never refuel your airplane or what have you, but that is what we do with satellites. Now, I did say they are constantly moving due to physics, but if you want them to deviate from just that natural, predictable trajectory, you need some energy to do that. And there are advancements in energy sources and discussions of on-orbit fuel depots, which will all greatly help. But it is important to remember that space is very big. And so even with improved efficiency or just, energy sources and maybe how many possible fueling depots there could be on orbit, the vastness of space still imposes some very sort of unique limitations from an energy perspective. So all that said, really, the bottom line for this paper, sort of why it was written, is space is not intuitive to most folks, including a lot of people that are defense strategists. And so, really want this paper to serve as like a foundational, educational type of document, so that as there are more, discussions and developments of strategy and important decisions being made, that these, very real realities or feasibility kind of considerations are taken into consideration.
Yes, of course. And, I don't want to disappoint our listeners, fans of sci-fi, but it's always good to keep expectations aligned when it comes to imagining and planning for the future, right? And it's really, everybody, it's really an interesting paper. I do encourage you to go. So how can people access it, Rebecca?
Yeah, that's a great question. Hopefully we can drop a link in the information. But so the website ultimately is csps.aerospace.org. And we've got a whole bunch of different papers there. But the main paper I wrote is there, even along with a short YouTube video that includes some animations to help sort of show how some of these maneuvers work that, again, are sort of not part of most people's everyday lives or in comprehension. So encourage folks to go check that out.
We are definitely putting the link as well to help everybody. But, Future Hacker, we are always here trying to expand our minds to future possibilities, right? And this paper, my understanding is that it considers technology as we know it today. But is it possible for us to advance in ways that would allow us to look more Star Wars like and have, all those maneuvers and speeds and power, or still trying to be creative here and thinking about all the advancements, it's a no-no?
So really in the paper, we focus just talking about the physics of space and really have it pretty agnostic to the current state of technology for the most part, because while yes, our technology will improve in the future, physics is probably going to be the same. And so, this is just sort of a given regardless of humanity's advancements. Science fiction movies, again, which I love, have definitely conditioned people to believe that, we just need certain advancements and we'll be able to do some pretty crazy things. Again, advancements will definitely help. But, take, for example, people maybe believe that advanced propulsion systems might enable travel in sort of more of those Star Cruiser depicted ways and more like straight lines as opposed to these elliptical dances I was referring to earlier, and therefore sort of effectively unconstrained by orbital mechanics. However, in order to travel in a straight line or something resembling a straight line around Earth's orbit, you would need orders of magnitude more of energy than what we currently have today. And depending on sort of how far you want to travel in Earth's orbit, say from low Earth orbit out to geosynchronous Earth orbit, so it's sort of the full stretch of stuff that's around Earth, you would need like 3, I think, orders of magnitude more of energy than what is currently available. Now, separate from having the energy available to do that kind of maneuver, the spacecraft would also need to survive the immense forces generated by accelerating that fast. And that would be in itself another sort of engineering feat that we need to do. And I don't see either of these things happening in our lifetime, but really more to the point is, why is that desirable? And sort of a mantra I've been having these days is, I think people need to stop fighting against orbital dynamics and learn how to use it to our advantage. And so, instead of trying to force space-based activities to resemble that of air domain or just other terrestrial-based activities, we kind of just need to learn to think sort of out of the box and, some innovative thinking here. And I think that is what's really exciting. Again, of course, advancements in technology and energy sources and propulsion and everything will definitely help us. I think we just need to sort of change our mindset in terms of how does that help us and what do we do with that new technology?
Yeah, it makes a lot of sense, Rebecca. Changing gears, I've heard that one of the major concerns with conflict in space is that it could generate debris, right? So space junk to, most of our listeners. So what are the risks of space debris, like when a satellite of any space object collides or explodes to the space environment and to Earth?
Yeah, the space debris issue is a growing problem, regardless of conflict in space. Debris is created when two objects collide, whether accidental or intentional, or even just a dead, non-maneuverable satellite becomes a de facto piece of space debris. And space debris is especially harmful in space, given the speed at which objects move, right? Like I was saying, 10,000 miles per hour. So a piece of debris the size of a quarter or something could destroy a fully functioning satellite. I'm going to use some sort of approximate numbers here since things are constantly changing. But, since the space age began more than 60 years ago, humans have put about 10,000 satellites into Earth's orbits, and about half of those are still on orbit, and about half of those are actually operational, which means there's already thousands of just sort of dead satellites orbiting around Earth. There are also proposals for mega constellations with hundreds to thousands of satellites. Some of those will become a reality. So, basically, every month, every week, not quite every day, there are, more satellites being launched. And so this number is constantly changing. Space is constantly becoming more congested. And I did say space is very big. And for a long time, we were sort of able to sort of rely on that fact to say things would be okay. But as we have, hundreds and thousands more satellites up there, that means we need more situational awareness and coordination in order to prevent accidental collisions. And this becomes increasingly difficult when a high percentage of these objects are debris. And, because they can't move. And so it's a lot harder to coordinate things moving out of the way or what have you. Also, some of these things can get quite small and be harder to track. There are currently over 20,000 objects that are the size of a softball or bigger that are being tracked. And well, that's twice the number of objects you said we've ever launched. And that is because there is debris already up there from satellites colliding with each other and creating more stuff up there, more individual pieces. So from a conflict perspective, there are things called anti-satellite weapons, or ASATs, which is basically just a missile or of some sort hitting a satellite and destroying it physically. So, and there have been multiple tests of these weapons over the past number of decades. For example, in 2007, China did an ASAT test and generated thousands of pieces of debris from that. Some of that, or much of that, is still up in space. As recently as this past November, Russia did an anti-satellite test against one of its own satellites as well, and that generated over 1,000 pieces of debris that have been identified so far. And so some of it is depending on what altitude these ASAT tests occur, sort of correlates to how long the debris will be in space. These are all been in low Earth orbit, and over time, things at low enough orbits will sort of fall back down into Earth's atmosphere and burn up, but that can take a very long time. And there's a lot of things in low Earth orbit, a lot of satellites. And so there's a lot of talk about trying to keep space clean. And even just a week ago, Vice President Harris recently said that the U.S. would have a self-imposed ban on anti-satellite missile testing with the goal of making it an international norm for responsible behavior in space. And so just to sort of put a finer point on this, given the physics of space, debris does not discriminate based on the ownership of a satellite. So again, in the context of conflict, the secondary effects of an ASAT can have consequences for commercial and civil assets. So with that Russian test back in November, given the orbit that they did this, it actually put the astronauts that are on the International Space Station at risk. And they actually even had to sort of prepare to need to abort back to Earth because they were worried about pieces of debris from that test hitting the space station.
I just wanted to understand it better. So currently, there's no global, rule or legislation or governance. I wouldn't even know the word to use, but to make sure that, when a country does that, they have to be responsible and somehow manage it. Or is it something in development? Or is there this rule, but people are just not following it?
Yeah, so there's no explicit rule saying that it's not allowed per se, but there's a lot of desire to make it considered unacceptable to do, which is what Vice President Harris's comments basically is, right? The goal of making it an international norm for responsible behavior in space. And so there's a lot of talk these days about generating norms of behavior for space activity. And so things like this and broader efforts to create a more sustainable space environment are sort of a core part of that.
Okay, I get it. Another question, and please correct me if I didn't understand it right. When I was researching about it, my understanding is that you have, when talking about, avoiding satellites that are not being used anymore, just orbiting out there, there are two types. The satellites that are below 600 kilometers, they could naturally deorbit within 25 years due to drag from the atmosphere. Is that correct?
Yeah, so depending on what altitude a satellite is at, it will naturally deorbit and fall into Earth's atmosphere just due to the atmospheric drag at these lower altitudes. And so to your point, yes, below a certain altitude within a 25-year time span, a satellite will fall into Earth's atmosphere and burn up. And for a while, the sort of general rule has been that you need to get rid of your dead satellite after 25 years. There's a lot of talk, again, in terms of making that a lower number because 25 years is ultimately a long time. And there's just more and more activity in space, more and more satellites being launched. So, I mean, you could even take, like SpaceX's Starlink sort of whole philosophy is they're in very low Earth orbit and they burn up pretty quickly. And so it's sort of just this constant replenishment kind of schema. But I mean, your general concern about, higher orbits and what does that mean and everything is very much, a big discussion point. And there are companies out there doing things to help satellites deorbit faster. So sort of having a a service that can sort of help move your satellite out of the way or help it deorbit faster, something you pay for to get it out of congested environments more quickly than just what physics would provide. So there's a whole sort of multi-prong approach out there of different ideas and ways to try to make space more sustainable.
It looks like there's a whole market to explore there as well. So a lot of opportunities for startups maybe, right? Rebecca, I have a last question for you. So considering all the tech advancements and that, we've been discussing here on the show, what do you think conflict in space will look like in the coming decades?
So space is already a contested environment, and we can even just see recent examples of, say, Russia jamming satellites with the ongoing crisis with Ukraine. And so there are already versions of conflict in space happening right now. I think, other types of non-kinetic threats like cyber will also pose threats to satellites. So, while the point of my paper was how the physics of space is different and how we need to understand what that means in the context of conflict and everything else, that doesn't mean that advancements, on Earth, weapons of choice, so to say, on Earth don't also extend to space. These things are very connected to each other. I mean, even in the very real sense that satellites talk to ground stations on Earth, and ground stations are something that could, have some sort of weapon against that to harm it, and that would harm your space-based capability. Or again, just, cyber as being a up-and-coming area, as it were, to cause harm. And so satellites are not exempt from that by any stretch. And so I think some of the same trends you see and think about down on Earth will extend to space. Again, it's just the way in which it's employed will have to take into account what is unique or different about space. So nonetheless, though, if you are looking for a Star Wars style space battle, you will be waiting a very long time.
Got it. That's super, super interesting, Rebecca. Thank you so much. And, I'm wishing all the luck with NASA. It's a dream that I hope you'll never give up, because it will be really cool to have you back on the show here to talk about your experience personally there and up to space. So thanks, everybody, for listening. Rebecca, if you have any final words, please feel free. I'm going to leave it with you, but it was a great pleasure to have you with us.
Yeah, no, thanks for having me. Like I said, I hope people can get excited about the idea of coming up with new and innovative ways to think about how to navigate the space domain instead of trying to force it into sort of what we already know from other domains. But other than that, just encourage folks to check out the paper.
Future Hacker. Life. Path. Future.